Good morning. Today we are going to present the tutorial of Daccosim to create the tank barrel use case. This use case is divided in 4 components that basically are the control of the tank and the tank itself, the control of the conveyor and the conveyor itself. Then we are going to model this as it's presented here. So we have 4 FMUs and the data exchanges between them are represented in these arrows. So let's go to the Daccosim environment and we're going to represent this use case. For that, we have prepared here a folder in which we have the 4 FMUs and the Daccosim editor. So we are going to double click on it and we are going to start modeling this. Here we have the palette in which we have all the components that can be used in a simulation graph. So we are going to start by adding an FMU into the canvas and we are going to use the C1, that is the control of the tank. So we have added it and here we are going to put tank control for clarity. Here we are going to add the tank itself. So I'm going to just set the label as it is now. Here the control of the conveyor. So here I'm going to set conveyor control. And finally the barrel itself, the barrel conveyor. So here it is. Okay. Let's locate them correctly. So now the next point is to draw all the arrows, all the data exchanges. So according to the diagram, we are going to have a data exchange from here to here, from here to here, and from here to here. To make the arrows, we just need to drag from the center of the block, and it automatically understands that you want an arrow and you move it into the target. So once we have the arrows, we can, for each arrow, express all the data exchanges between these two blocks. To do so, we make a double click on the arrow, and here we see that the input that must be filled in the tank is the valve. So for doing this, we can do a double click here, and we can select the variable of the tank control that can be used. So in this case, we are using the valve and the connection remains like it is. The output of the tank control valve will be feeding the tank input valve. Okay, now we go with this arrow. Here the connection is just to provide the amount of water that is flowing from the tank to the barrel. So we just need to fill this last one, and we are going to connect the outflow of the tank with the inflow of the conveyor. And finally, the two control variables of the barrel conveyor that are outward and size. So we are going to set it. We have finished the modeling of the co-simulation graph, but now we need to specify the execution parameterization. For this, we click here in this symbol, and we are going to set the stop time in 18 seconds. The step size we want, in this case, this one. And since we are using the Spanish version of Excel, we want to use the comma as decimal separator because it's better understood by this version of Excel. In the variables to export, in this tab, we want to plot, in this case, for instance, we would like to plot the control, all the control variables, the valve, outward and size. We want also the inflow of the barrel conveyor. And finally, the water, that is the level of water that the current barrel is having at the given time. So well, it is finished. And now if we want to check the correctness of the graph, we can click here and everything is correct. Next step is executing this co-simulation graph. To do so, we click here. And well, before executing it, we must save this co-simulation graph. We click on yes, and we are going to call it tank barrel. So once it is saved, it starts the co-simulation. Here we can see the parameters we choose. And well, it has finished correctly. And here we have the path to the file in which the results are placed. So we can click on it, and then Excel is open, and automatically we can see all the variables that we decided to export. So for instance, the water, here we can see the chart. Here what we can see is that every time we have a point here into the one, a barrel has been totally filled. Here we can see that there is a barrel that wasn't filled, completely filled, and the reason of this was because it was aborted. So here, if we plot the abort, we can see that at that time the barrel was aborted. Here we can see it. Then, for instance, here the water was always until the 1. This will be the 100%. But here we can see they started to be the 50%. So here probably the size of the conveyor control was decreased, as we can see effectively. Here we can see that it was in 100, reason why all barrels were filled until they reached the 100. And here we start to see that they are 50%. So well, this is the co-simulation graph that we have designed today. We have learned to model it, to configure a co-simulation graph, to execute it, and to visualize the results. So well, thank you very much for your attention, and we'll be giving more tutorials so that you can learn how to use Daccosim. Thank you very much.